So regarding the anti-elimination in the E2 mechanism of dehydrohalogenation reaction, this means the hydrogen, beta hydrogen, must be able to adopt an anti-position to halogen in order to be eliminated. So if we have this compound, bromine is trans to the two methyl groups on the adjacent carbon. This alkyl halide cannot have elimination reaction because there is no beta hydrogen that is anti to bromine. In the open chain form, we can always rotate the bond to make hydrogen anti to the halogen. But when we have a ring, the bonds cannot be rotated freely. Then we have this issue. So let's take a look at the chair conformation. One of the chair conformation has all the bonds, all these substituents on equatorial position. As you can see, the beta carbons are the carbons here, right? And the hydrogens on these carbons are on the equatorial position. They are not anti to Br. The methyl groups are anti to Br, right? So there is no anti-hydrogen to Br to be eliminated, and this compound cannot have the elimination reaction. You can also try the chair flip to make all the bonds on equatorial position, and you will see in that case there is still no hydrogen anti to Br. Okay, I would recommend you do that and find out when the Br is on equatorial position, what are the atoms anti to Br. Lastly, let's take a look at the E1 mechanism for dehydrohalogenation. Similar to the previous E1 for dehydration, this is also a unimolecular reaction. It's a first-order reaction, so the rate is only related to the concentration of the alkyl halide. It will have nothing to do with the concentration of the base. The first step in E1 mechanism is the ionization. The alkyl halide will dissociate by hydrolytic cleavage of the carbon-halogen bond, and this will give the carbocation as the intermediate. The formation of the carbocation is always the slowest step in the reaction. Second step is the deprotonation. So we have a weak base, ethanol here, that can act as the base to grab the beta proton from the carbocation to give the alkene product. This deprotonation step will be a faster step. In the E1 mechanism, as compared to E2, we don't have a strong base. Okay, strong base, E2 will be favored. And for E1, we have a weak base, such as ethanol. All right. Now, the source of carbocation is different for E1 mechanism of dehydration of alcohol and dehydrohalogenation of alkyl halide. So in the dehydrohalogenation of alkyl halide, the alkyl halide ionizes directly to give the carbocation. In the dehydration of alcohol, it's the alkyl oxonium ion dissociates to form the carbocation. That's the only difference between the E1 mechanism for these two reactions. Alright, lastly, I want to introduce you regarding to different types of bases that can be used. You've seen sodium alkoxide, the conjugate base of ethanol. And I mentioned that the strong base used in E2 elimination will always be the bases that are stronger than hydroxide. So alkoxide will be one of the choices. 1-alkoxide, the conjugate base from tert butyl alcohol, like shown here, it's the potassium T-butoxide. This base, we call it a bulky base because of the size close to the oxygen. Okay, the size of the alkyl group close to the oxygen. Due to the two branches, that makes the base relatively big compared to methoxide or ethoxide. So the big base cannot get to a sterically hindered place to grab hydrogen. For example, if we have this alkyl halide, a secondary alkyl halide, okay, there are two beta hydrogens. One is a primary, the other is a secondary. The secondary hydrogen is inside the chain, so it's more sterically hindered. And the potassium T-butoxide can only grab the less sterically hindered hydrogen, which is more easily accessible. As a result, here is the product of the reaction. It didn't follow the Zaitsev's rule. Okay, so only the small strong base follows Zaitsev's rule to give the more stable alkenes. When we have the bulky base, the steric reason will control the reaction. The easily accessible hydrogen, the more available hydrogen, less sterically hindered hydrogen will be removed. Okay, so that's the exception to Zaitsev's rule.